Hello friends, three more L'Hopital examples. Let's do it. Limit x towards 0, we get tangent of x minus a sine divided over x minus sine of x. Well, since we know that tangent, sine, and x are all behaving equally next to 0, it should be something like 1, right? Well, let's see. So if we put zeros for x in each case, we're going to get 0 divided by 0. Both parts, the numerator and the denominator correspondingly are differentiable, so we can produce derivative by the rule of L'Hopital. Let's see what's happening. The tangent is giving us 1 divided by the cosine squared of x minus cosine of x divided over 1 minus cosine of x. Well, is it better or worse? If we put 0 for x, it's going to be 1 minus 1 in the numerator and 1 minus 1 in the denominator. So once again, in both cases, it's going to be 0 divided by 0. So let's do it again. And now, well, should we simplify it somehow? We can bring it maybe to the same denominator. I don't think I have to do it. Okay, I'll produce a derivative by the chain rule. So this is cosine to the power of minus 2 of x. Its derivative would be minus 2 cosine to the power of minus 3. So basically minus 2 times 1 divided by the cosine cubed of x. And the inner derivative of the cosine is minus sine, so plus we have a sine here. And we have a sine there. Divided over, well, it's just becoming a sine. And now we can take sine out, right? So this is a limit. X towards 0, we can take sine out in the numerator. It's going to be 2 divided by the cosine cubed of x plus only 1 divided by the sine of x, which is perfectly cancelled. And if we put for x 0 now, it's going to be 2 divided by 1 cubed, which is 2, plus 1, it's 3. Pretty bizarre, isn't that? So the quotient of tangent to x and sine to x could be 1, but you see, you must be really careful to produce these kind of limits and rigorously without, well, believing it could be something like 1. It's not, it's 3. So 3 times as much as one would expect here. Okay, let's do one more. I think I'll do 2 more. So 3 examples in each video. And maybe a little bit of explanations as well. So let's see, limit x towards pi divided by 2, tangent of x divided over tangent of 5x. Okay, so what's happening to tangent is exploding towards pi divided by 2. It's getting to plus infinity. From the left-hand side, from the right-hand side, it's going down to minus infinity. So it's not given from which side we're approaching pi divided by 2, but that would be infinity by infinity if we would say x doesn't matter whether it's pi divided by 2 or 5 times pi divided by 2. In both cases, we're going to get trouble. So let's produce its derivatives. We're going to get 1 divided by the cosine squared of x in this case, 1 divided by the cosine squared of 5x in this case, and then one more 5 in the denominator. If I'm putting pi divided by 2, what am I getting in the numerator? It's just 0, right? I have a problem. I would be dividing by 0, and I would be dividing, so I can rewrite it now. It's a limit. Let's take 1 divided by 5 outside. So cosine squared of 5x is coming up. Cosine squared of x is remaining in the denominator. What is the next step? So if I'm putting pi divided by 2, I'm getting to 0 divided by 0, which I'm not going to be doing. So let's do L'Hopital once again. It's limit x towards pi divided by 2. What do we have here? We got 2 cosine of 5x times sine of 5x times 5. And in the denominator we got 2 cosine of x times, I think it should be minus, right? In both cases, so that's all right. Okay, is it getting better? Well, we can take 5 out. It's going to be canceling with this 5. And then we have a limit x towards pi divided by 2. We have sine of 10x, applying the doubled angle formula, and the sine of 2x. Is that somehow better than the previous result? Well, sine of pi divided by 2 is what? If I put pi divided by 2 and multiply it times 10, I'm gonna get 5 pi, sine of 5 pi. So 0, and sine of pi is 0 again. So, let's do it again. Limit x towards pi divided by 2 minus cosine of 10x times 10 divided over minus cosine of 2x times 2. What do we have now? If I put pi divided by 2 in the denominator, I'll multiply times 2 now. So this is the cosine, so minus minus gives me plus, of course. That gives me 5. And now, this is cosine of pi. Cosine of pi is minus 1. This is cosine of 5 pi. So let's see. You remember cosine is 2 pi periodic, so I can take 2 pi away, 2 pi again, so this is the same as cosine of pi. So what are we getting? We are getting cosine of pi here, which is minus 1, and cosine of pi in there, which is minus 1 as well. So the result is simply 5. Of course, now we know, since we proved it, I would immediately maybe be able to see it at some point. This is somehow 1 divided by a fifth, and this is 5, but now we know it for sure. Let's check. I hope I haven't made any kind of mistakes, but that seems to be right. I don't know. I'm computing it live as usual, so I don't know in advance what is the result. I'm just checking some questions here without knowing what the result would be. All right. And the last question for today would be limit. Well, this is one of the most important questions. Let's do x to the power of 5, which is given in the Demidovich book, but that could be x to any other power of n, whatever we are picking. So basically the idea is the result is infinity. Why is that the case? Well, each time we're using L'Hopital's rule, and we can use it here because we're allowed, because both parts are differentiable, e to the power of x is running towards infinity, x to the power of 5 as well, but the speed at which e to the power of x is running towards infinity is way bigger. And this is the reason why e to the power of x is winning. How can we see it? Well, you see, the point is, if we have a limit x towards infinity here, the derivative in the numerator is giving us still e to the power of x. In the denominator, we are going to get 5x to the power of 4. So you see the degree of the denominator is decreasing, it's dipping down, and if we do it one more time, then it's going to be a cubic function. E to the power of x doesn't know anything, right? And here we get 20x cubed. So the degree of the denominator is going lower to get lower and lower and lower and lower, and at some point it's going to be a constant value. And at the same time, e to the power of x, on the other hand, is increasing without any bounds. So the point is, e wins against any polynomial function. Okay, that's it for today. Thanks for watching. I'm not done with L'Hopital. It's going to be a few more videos. See you guys.